Students, this is Unit 3, Preview Videos, Lesson 3.7, side, 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 angle, angle, side, and formal proofs. You'll look here, make sure you get the date, time, location, and a parent or guardian sign off. Let's recap what we've learned from the last lesson. We learned that when triangles are congruent, there's a total of 6 pairs of items congruent. Three pairs of congruent sides, and 3 pairs of congruent angles. Then we discovered that there are shortcuts. And in these shortcuts, if these minimal things happened, then the triangles were congruent. Everything else was forced to be congruent. And of course, that was side, 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 angle, side, angle, and angle, angle, side. Or that last one could be side, angle, angle. Remember, there's something called the ambiguous case, which is 2 sides and then an angle where the angle is not squeezed between the sides. That does not work. The way you remember that is no bad words spelled either way. Then we learned to use the process of gift. Let me demonstrate that process with these 2 items. This is by far the most important process for you to master in working with proofs. So you start by taking the given and marking it on the diagram. We are given AC bisects BD. So we trace AC bisects BCD going this way. It also bisects BAD. BAD. Now you do implied and freebies together. So what's implied by that bisector is if BCD is bisected, these 2 angles are congruent. And you can always add numbers to angles to make it easier to describe them. So I can label those angles 1 and 2. And because of the bisector going the other direction, these 2 angles are congruent. You can always add numbers 3 and 4. One of the freebies here, vertical angles, reflexive sides, reflexive angles, would be the fact that AC is going to be congruent, you write it like this, to AC. That's called the reflexive side. Now we talk through and ask ourselves, why is this triangle congruent matching with one of these hatch marks? You go through and you ask yourself right here, I have a pair of angles. And then I have a pair of sides. And then here I have a pair of angles again. So we see that this shortcut in this scenario is going to be angle, side, angle. That talk-through part is really important. Let's try another one together. Point C is the midpoint of BE. So we physically trace C. I'm going to label it midpoint. I physically trace B to E, so I know what I'm talking about. And then A to D, it's the midpoint going this way as well. Cross items out when you account for it. That's given. Now we do implied and freebies. Implied by that midpoint is that BC and CE are congruent. So we have a pair of sides. Also a freebie, pair of vertical angles. Because of that midpoint going the other way, another pair of sides. Be very careful you just don't randomly mark everything equal. You only work through what's implied by the given, and then of course your freebies, things that are always congruent even when they're not marked. So we see here that we have a pair of sides, then a pair of angles, and another pair of sides. So we have side, angle, side. Then we talked about narrative proofs. Narratives are what are called informal. Informal. Informal proofs are things where you just write sentences. It's kind of freestyle, it's open-ended, it doesn't have a lot of structure to it, other than what's called formal proofs. Then you have your two formal proofs, and they are the two-column and the webbing. Two-column and the webbing. Two-column and webbings are much more structured. So let's go over the informal here one more time. So the most important thing is to walk yourself through gift. Given, implied, freebies, talk through. So we are given the fact that AC bisects BCD. So I'm going to trace AC, BCD. I write the word bisect. And it bisects BAD, going this way as well. I am done with my given. Implied by the given. It is implied that 3 and 4 are congruent because of the bisector. That gives me a pair of angles. And that right here, 1 and 2 are congruent because of the bisector. That gives me another pair of angles. Cross things out as you account for them from the given. Freebies, we look for vertical angles, reflexive sides, and reflexive angles. And you can see here that we have a reflexive side, AC. That is a side. So we talk it through. Why are these triangles congruent? And you can see already that it's going to be angle, side, angle. The easiest way to structure your writing here is through that shortcut. I will demonstrate. You can talk about the first angle, and you can talk about the side, then you can talk about the other angle, and remember to hit your target. Your target is trying to get triangles congruent. So your final conclusion, always make sure you actually hit your target. The final concluding sentence here is going to be something like this. Finally, comma, triangle ABC is congruent to triangle ADC because of angle, side, angle. Okay, students, I want you to write your own narratives here, your own narrative sentence, and then grab your red pens and let's check them. But you're going to write your own narrative sentence. I'm going to set a timer for 2 minutes. You have 2 minutes to write your own narrative sentences. Go. Fast forward if you finish in under 2 minutes. Alrighty, students, let's see here. Check your work with mine. See if you are close in the way that you phrased it. Make sure you have all the details here. We're going to start with that angle right there. We're going to say, since it is given that AC bisects CD and angle 1 is congruent to, excuse me, that's 3 and 4 for that one. Angle 3 is congruent to angle 4 because of the bisector. That should have been something along your first sentence there. And you use congruent sign, not equal. I just can't type a congruent sign, so I'm going to add it here. And then your side. This one looks a little strange, but your side here is you just write AC is congruent to AC because it is reflexive. So AC is congruent to AC because it is reflexive. So here we have a pair of angles. Here we have a pair of sides. And you want to say something around your last one? It is the fact that due to, not by, due to the bisector of AC cutting angle BAD in half, then angle 1 is congruent to angle 2. Close to that. You have to connect the fact that the bisector and those angles are congruent. We hit your target ahead of time so that you would remember it. So those are informal proofs. You just write sentences. You make sure you include all the details. Now we're going to get into what are called formal proofs. That was informal. These are formal. So we're going to do the same thing, doing a formal proof. This is called a two-column. You've seen these before, especially on Alex. It's the most common. We're going to walk through gift again, given, implied, freebies, talk through, given, implied, freebies, talk through. And we were told that AC bisects BCD. Go like that. It's a bisector. Right, bisect. And then it also bisects BAD going this way. Bisect. I cross that information out. Implied and freebies. Because of the bisector, I go like that. I know 3 and 4 are congruent. It's a pair of angles. 1 and 2 are congruent. Another pair of angles. And then I have my freebie down the middle, AC. Pair of sides. You talk it through, I see that my shortcut here has to be angle, side angle, and my target is to somehow get these two triangles to be congruent. So in your two column, you put your how on the left and your why on the right. It reads like sentences. There's no rule that says you have to put all the given in one. In fact, I am going to split it up because I like to follow the shortcut. The shortcut is going to talk about an angle, and then a side, and then another angle. So I'm going to follow that to help structure my proof. So my first angle that I worked with was BCD. And I know that information because it is given. Now, because of that, I can get angles 3 congruent to angle 4, and the reason is because of the bisector. So there's my first angle. Now I'm going to go for my side, and it looks a little strange when you write it down, but when something's reflexive, it's congruent to itself. So I'm going to say reflexive side, and there's my side. Let's go for our other angle here. AC bisects BAD because I know it's given. Now because of that, I get angle 1 congruent to angle 2. There's my other angle. Why do I know that? Because of a bisector. I'm only trying to get the triangles equal. I am now completed my shortcut angle, side angle. So I can conclude by saying that triangle ABC is congruent to triangle ADC, and the shortcut used is angle, side, angle. How on the left, Y on the right. Some of you might like the freestyle of a narrative proof where you just kind of write a paragraph. Some of you might like the neatness of a two-column, just left and right. And then there is a third style called webbing. This is my personal favorite. It is the only one of the structures that shows you how things fit together, like puzzle pieces, how things fit together like puzzle pieces. So all three of these show how things fit together like puzzle pieces. So the first one, we're going to do the exact same proof, but I'm going to show you how you work it in a web. So we mark our given information on our diagram, the fact that AC bisects BCD, and the fact that it also bisects going this way. I've accounted for my givens. Implied, I get congruent angles because of the implication there. I get congruent angles here. And then one of my freebies, right down the middle, of course, again, is our AC. And we've done this now twice, same one. We get angle side angle. Notice, no naked diagram. All your thinking gets done on the diagram. So this shows that now triangle ABC is congruent to triangle ADC. Webbing shows how things fit together. For example, there's two pieces to my original given, and they are, I'm going to show how those pieces, the fact that AC bisects angle BCD, that was one part of my given, and the fact that angle BAD is bisected as well. How do I know those two pieces of information? It is given. Now, why did I split those up? Because I know they're going to feed into two other pieces of information logically. So right up here, I know because of AC bisecting BCD, I know angle 3 is congruent to angle 4. That's the how. The how goes in the box, the y goes in between. The y was because of the bisector. Over here, that gave us angles 1 and 2 because of the bisector. This gives me a pair of angles. This gave me a pair of angles. So you're probably wondering, what's that middle thing doing there, kind of freestanding? Well, it's freestanding because it's a freebie. There's nothing else feeding into it. And if you're very astute in your observation, I'm again following the acronym angle side angle, and that's how I've structured to show how those pieces fit together. Okay, the bisector is not physically connected with this middle piece because this middle piece is freestanding. It's a freebie. So my freebie is this. AC is congruent to AC. And the reason is reflexive. Get out of the fat pen, it's hard to read that. A reflexive side. So now I come down here, and those three pieces feed into the same conclusion. Angle side angle allows me to write the fact that triangle ABC and triangle ADC are congruent, and the reason is angle side angle. So a web proof is the only one that shows how the pieces fit together. Some students will prefer this method if they have a highly developed ability to visualize pieces. Let's try one more together. We're going to use one that we did in the beginning. For following given, implied, freebies, talk through. It is given that point C is the midpoint of BE, so I trace it, circle, midpoint. I'm going to use two different colors here. It's also the midpoint of AD, going this way. Now, implied and freebies. Because of the midpoint for the green, it's implied that BC and CE are congruent, pair of sides. I also know that I have freebie vertical angles. And then the C is the midpoint of AD, so that means A to C and C to D have to be congruent. That's another pair of sides. No naked diagrams, implied and freebie. Talk through. So you're going to talk yourself through it. I'm trying to again prove that one triangle, ABC, is congruent to the other triangle. And I can already see my shortcut involved is going to be side, angle, side. So that's how I'm going to structure what I'm doing. So in webbing, I know this one piece of given information gives me something else. So I'm going to write this. C is the midpoint of BE. And then right here, C is the midpoint of AD. Why do I know those? Because it's given. The logical conclusion of C being the midpoint of BE is the fact that the side, BC, is congruent to BE. Why do I know that? Because the definition of a midpoint. That gave me a pair of sides. Coming over here, I know because of that midpoint of AD, A to C, that gave me another pair of sides. Angles. Now you can name the angles if you want. You have to be careful you align the vertices. So watch, I'm going to go B, angle BCA, short, middle, long, is congruent to angle and short, middle, long. Short, middle, long, ECD. You have to make sure you align those vertices. Or a shortcut is simply add numbers to any angles. You can always do that. If I add 1 and 2 there, I could just say angle 1 is congruent to angle 2. And why do I know that? It is not given. You want to cross that out. That's true because of vertical angles. Now you have these 3 pieces of information, and it spells angle, side, angle, side. I like you to fill in these 2 blanks on your own. What is the logical conclusion of all these pieces fitting together? You fill in those blanks completely by yourself. Pause the video and fill in the blanks. Okay, welcome back. I'm not going to fill in those blanks for you folks. I'm not even going to show you the correct answer. I expect you to have logically figured that out on your own, and I'll be looking for that when I check your preview notes. Now, this last one, I'm going to walk through gift with you, and then you are going to do this one on the right on your own. And we're going to be checking it in just a moment. So, given, implied, freebies, talk through. Let's see what we're trying to do here. Given, implied, freebies, talk through. Let's see, we are given the fact that PQ and PR are perpendicular. Let's physically trace that. PQ and PR are perpendicular. That means they make a right angle. We're also told that SR and SQ make also a right angle. We're told that PQ and SR are parallel. Okay, that is all I've accounted for the given. We're trying to prove, again, that this triangle ABC, whoops, that should not be ABC. Let's change that. That's going to be triangle RPQ is congruent to triangle. So I went short, long. So we have to go short, long, QSR. Notice the direction there. Triangle QSR. Obviously, that was a cut and paste leftover from the previous one. Now we're going to look at implied and freebies. Get a closer look here. Implied and freebies. It is implied by the right angles that these are congruent. So because of the right angles, we get congruent angles here. So I have a pair of congruent angles here. I also have a pair of congruent angles here. That's implied. It's also implied because of the parallel lines that there's going to be armpits of the Z going on. So I know angle 3 has to be congruent to angle 4 because of their alternate interior angles. That gives me another pair of angles. We're done with what's implied, so now we're going to hunt for our freebie. And our freebie is side RQ, because RQ is congruent to RQ. It's reflexive. Okay, now you have to figure out, we obviously have two angles and a side. Now you have to figure out whether this is a hamburger, angle, side, angle, or whether it's a tail, angle, angle, side. Again, your choice is this. You're trying to figure out if I have a hamburger situation or if I have a tail situation going on here. You make that choice. Now, what I'd like you to do is you're going to attempt to fill in this page completely on your own. And then you're going to restart the video to check. Okay, welcome back. Let's see how we did here. It was given the fact that PQ is perpendicular to PR. And the fact that SQ and SR were perpendicular. And we know that because it's given. And then we also knew that PQ was parallel to SR. So here we have, because of that right angle, that gave us, the right angles gave us angles. Let's see, what number did we put there? 1 and 2. We know that angle 1 is congruent to angle 2. Why? Because perpendicular gave us right angles. Same thing was here. Angle 3 was congruent to angle 4 because perpendicular gave you right angles. Here we have a pair of angles. Whoops, forgot to account for the side. You were copying. You just copied it all wrong because I wrote it all wrong. Hopefully you weren't copying. Let's fix this. There's actually 3 pieces going on here. Okay, so first we had to get angles 1 congruent to angle 2. And that was because of both the perpendiculars. So that was PQ, PR, SR, and SQ at the same time. PQ perpendicular to QR, or PR. And then we had SR and SQ. Those perpendiculars gave us 1 and 2. And the reason why? Because we have right angles due to perpendicular lines. Then we had the parallels. PQ and SR are parallel. From that, we got our armpits of the Z, which is angle 3 congruent to angle 4. Alternate interior angles are congruent. If you write armpits of the Z, that's perfectly fine. This gave us a pair of angles. Then we had another pair of angles, and the reason why this was freestanding is it's your free side. Freestanding, it is a free B, which is RQ is congruent to RQ. And that is because of reflexive. That gave us our side. This was a tail, not a hamburger. This empowers us to say that triangle RPQ is congruent to QSR. And the reason is angle, side.